Bio. This is Mr. B, and we are starting our last chapter of the year with this video today. And the title of this chapter is The History of Life. So we're going to take a look back at how basically we came to be and what evidence we have that kind of shows us maybe what we used to look like, how life came to be what it is today. So our first section is going to focus on one of the biggest clues that kind of helps us with the history of life, and that is the fossil record. So section 1 is called the fossil record. So first thing, hopefully we might know what this is already, but we got to ask ourselves, what in the heck is the fossil record? So our first important word here, this is definitely something you're going to need to know for the quiz, is the word a paleontologist. And this is a scientist whose job is to collect and study fossils. So that's how they spend all their time, is they collect and they study fossils. And then all the information that they collect and that they study is called the fossil record. So this is another really, really important thing. So paleontologists study fossils. All of the fossils that we have gives us information about our past life, and it is called the fossil record. And some specific things that the fossil record will actually tell us is that it will include information about the structure of organisms, so it's basically what their bodies looked like, how big or how small they were. We can actually tell what they ate by looking at fossils, and we can tell what ate them. We can tell what environment they lived, and that's again just based off certain adaptations that they might have had. And we can tell the order in which they lived. And so this is a big one too, the order in which they live. We can actually tell which organisms are older than one another, and there's two different methods we have for doing that, and we'll get to that later on in this video. So that is the fossil record. Again, paleontologist being an important word you need to know. Another important thing about the fossil record is that it provides evidence about the history of life on Earth. So obviously it is what all of the organisms that used to be alive on Earth today, and it also shows how different groups of organisms, including species, have changed over time. And so we've talked about with Darwin, how did he use the fossil record, and it's pretty simple. He used it for his theory of evolution because he could tell how either organisms had A, stayed the same over time, or B, how organisms had changed over time. And so evolution kind of goes hand in hand in here with our fossil record. However, our fossil record is not perfect, so that's a big thing. It is not perfect because it provides us an incomplete information about the history of life. Not every single organism that has ever lived has been fossilized, and we'll talk about why that is kind of later on in some of these videos. So it is an incomplete record. And another big thing is that over 99% of all species that have lived on Earth have become extinct, which means the species has died out. So we've learned what the word extinct means, but over 99% of all living things have died. That no longer exist. So we obviously don't have all of those things preserved. So that's again going back to how it's an incomplete record. And so now, however, we do have some records. So we have to actually know how these fossils actually came to be, and this will kind of be why we have some in certain periods of time and why we don't have others. So fossils are there's a wide variety of fossils. Some can be very large, incomplete, like Sue, the Tyrannosaurus rex that's up in Chicago. That's a very complete fossil, and they can be completely preserved animals. There's been woolly mammoths, the giant elephant-like creatures that have been frozen in ice, or they can just be small as a fragment. So it really ranges in what they can be, and most fossils form in what's called sedimentary rock, and we're going to talk about why here in a second. And sedimentary rock forms when exposure to the elements breaks down existing rock into small particles of sand, silt, and clay. So sedimentary rock is just kind of a layered rock that's made up of these three things right there. And so now we're actually going to take a look at a simple step-by-step thing of how a fossil forms. So first step would be that water would carry small rock particles to the lakes and the sea. So look, we have our dead fish here. It's going to become a fossil. So water brought some rock and particles to put on top of there, and so then the dead organisms are buried by layers of sediment, which forms new rock. So sediment is just formed by these small rock particles, and so those small rock particles build up on top of our dead organism, and then eventually it'll form a new rock, and then the preserved remains may be later discovered and studied. So basically, this is a simple definition, but the rocks just kind of form over top of it. The dead organism kind of either can leave an imprint on the rock or it can become part of the rock itself. And so that is how our fossils form, just very simply stating. And so now, once we find the fossils, we have to be able to interpret what in the heck does that actually mean. So Paleontologists, again the people that study fossils, they determine the age of fossils using two different ways. They use relative dating, so that's our first way, or radioactive dating. So those are two ways we can determine how old a fossil is, because what's the point of finding something in the ground if we can't analyze it and figure out actually what it means? So first thing is like, what information can we learn from each of these types of dating? So in relative dating, so this is a very simple one, and you might actually have another extra quiz in class over relative dating, so make sure you're ready for that, is that the age of a fossil is determined by comparing its placement with that of fossils in other layers of rock. So this will make more sense when we actually look at the picture, and just kind of breaking it down even more, as saying that rock layers will form in order by age, being the oldest would be on bottom with the most recent layers on top. And so if we take a look at this picture here, we can tell that this kind of seashell looking thing up at the top, this is our youngest fossil because it is in the youngest, it's in the top rock layer, meaning it is the last rock layer to form. And then as we go down, so the top in relative dating are our youngest fossils, and then as we go down, this fossil's older, this fossil's even older, this fossil's even older than that. And then down here at the bottom we have our oldest fossil because it is in the lowest rock layer. So relative dating is pretty simple. We just look literally where it's located, what rock layer it's in, and we determine how old it is by that. So that is relative dating, pretty simple. And then another kind of word to go along with relative dating are index fossils. And these are used to compare the relative ages of fossils. And an index fossil is just simply a species that is recognizable and that existed for a short period but had a wide geographic range. So it's important because it existed on all over the earth, so we know that it's going to be consistent, and it only existed for a short period of time, so we know exactly what time period it existed in. So it could be our index fossil, and this could be our little light blue curly Q right here. We know that these occurred all over the world around a certain time, so if we see things below that, we know they have to be below a certain age. If we see things above it, we know they have to be a more early fossil. So that's why an index fossil is important. And so our last type of dating is just to sum up relative dating, and it allows paleontologists to estimate a fossil's age compared to that with other fossils. So the big word here is estimate. It is not an exact science with relative dating. So our next type is radioactive dating. So scientists use what's called radioactive decay to assign an absolute age to rock. So they can actually give that this rock is 1 million years old or something like that. It's not just that this rock is older than that rock. And how this works is that some elements that we have that occur naturally in nature, like oxygen, carbon, things like that, are radioactive, and so they have radioactive properties, and they steadily break down into non-radioactive elements. And so radioactive dating is using the half-lives to determine the age of a sample, and a half-life is simply the length of time required for the half of the radioactive atoms in a sample to decay. And so this will make more sense, and then here's a chart, and so in radioactive decay, this is really kind of making sense. Scientists calculate the age of the sample based on the amount of remaining radioactive isotopes it contains. So if we know that it takes 5,000 years for half of this carbon to go away, we can measure the amount of carbon and we can say, oh, over half the carbon is gone, so now we know that that has to be over 5,000 years old. And some of the most important ones that we use is carbon-14, because it begins to decay when an organisms die, whereas carbon-12 does not, and it does not decay. So we can compare the amounts of those two, carbon-14 and carbon-12, and we can determine when our organisms lived. So that is it for our first part of the fossil record. Let me know if you have any questions.